Okay, greetings and bouncing salutations. This is the Mighty Eagles Tuition Academy. Okay, this is the Mighty Eagles Academy. Okay, so now under this presentation, we'll be looking at Science Paper 1. Okay, we'll be looking at Science Paper 1. The topic known as simple pendulum. Okay, pendulum or simple pendulum or a pendulum. Okay, so now under these pendulums, there are some basic things that you need to understand. The first one is the definition of the same pendulum. Okay, the definition of the pendulum, and also the things that are affecting the period of the pendulum. Okay, so we'll be looking at the definition of the pendulum, the things that are going to be affecting the period of the pendulum, and also how you come up with the period. Okay, how you come up with the period. So by the way, the word period simply means the time. Okay, the word period according to pendulum or according to waves simply means the time. Okay, but under biology it means something else. Okay, so now this is not biology, this is physics. Okay, so now period just means the time. Okay, the time. Okay, then another thing that we'll be looking at is the frequency. Okay, the frequency of the pendulum. Okay, so the way we come up with the frequency here under pendulum is the same way we come up with the frequency under waves. So the formula is just one and the same thing. So the formula for you to come up with the frequency is equal to 1 over t. Okay, so this is capital letter T, which is the period. Okay, this is the period. Okay, so now let's start. Okay, so we are having this question here. Okay, so this is an introduction to pendulums. Okay, so please pay very much attention. Okay, please pay very much attention. These are examination questions. Okay, let's start with the first one. Okay, so now we are saying that it takes 2.08 seconds. Okay, it takes 2.08 seconds. This is time. Okay, so time is measured in seconds. Okay, time is measured in seconds. Okay, so it takes 2.08 seconds for the ball to go from A to C. Okay, for the ball. So this is the ball. Okay, this kasekwa. We call it a ball. Okay, it's a round thing like a ball. Okay. So to go from A to C and back to the midpoint B. Okay, let me just unfortunate that I didn't draw the diagram. Okay, let me just try and draw a rough diagram here of what the statement is saying. Okay, so the pendulum is going to look like this. So I was unable to draw it due to space. Okay, due to space. But here we are having this is the second question. It's having the diagram there. Okay, so let's use this as an example. Okay. Let's use this as an example. So this is a ball. This is also a ball. Okay, so this is our A, this is our B, this is our C. Okay, so now we are seeing directions from here also to here. Okay, so the statement is saying it takes 2.08 seconds. Don't worry. The question that you'll be asked will never ask you to come out to say that draw this pendulum. Okay. There will be no questions like that. Okay, the diagram will already be drawn for you. Okay, so the statement is saying it takes 2.0 seconds for the ball. Okay, this is a ball, like the way I put it here. This is a string. Okay, kantambo. Okay, kantambo. Okay, so for to go from A to C and back to the midpoint. Okay, and back to the midpoint B. So something which is like this. So the statement here is saying that it took 2.08 seconds. Okay, it took 2.08 seconds for this bulb to move from A to C and back to B. Okay, so the maximum distance the maximum time, not necessarily the distance. Okay, so the maximum time that the bulb took for it to swing from A to C and also back to B is 2.08 seconds. Okay, so now let's start. Now how to do the calculations. Okay, so it's very simple. Okay, it's very simple. It's very simple. Okay, so now let's start. So this is the explanation which is here. Okay, this is what this statement is saying. Okay, so I'll just try and remove these just for me to gather some space. Okay, let me just try and remove this thing just for in order for me to try and gather space where I can do the solutions from. Okay. Okay, it's out now. Okay, so now the statement is saying find the period of the pendulum. Remember from the preamble of this presentation, I said that period simply means the time. Okay, period simply means the time. The SI unit for period is seconds. Let me take that again. Period simply means the time. The SI unit for time is seconds. Okay, I guess it's clear. Okay, so let's start with the period. So let me first try and define what a pendulum is. Okay, what is this pendulum? Okay, what is just unfortunately that I don't have a pendulum in here. Okay, I don't have a good example of a pendulum. But as time goes on, I will try by all means to organize a pendulum so that we do it from the practical aspect or the pragmatic aspect. Okay, so now what is a pendulum? Now listen. A pendulum, by definition, this is just a body that is suspended from a fixed point. Okay, let me take that again. It's a body that is suspended from a fixed point. Okay, so that body is able to swing. Okay, it is able to swing under the influence of gravity. Let me try and use this thing as an example. Okay, so we are saying that a pendulum, by definition, this is just a body that is suspended from a fixed point. Okay, here. So this thing is fixed time. Okay, these things they are fixed here. So now they are able to swing. Okay, they are able to swing under the what? The influence of gravity. Okay, so these things are able, this both air and also the strings. I mean, they are able to swing under what? The influence of gravity. So now, in a nutshell, okay, in a nutshell, pendulum, this is just a body that is suspended from a fixed point and it is able to swing under the influence of gravity. That's the definition of a pendulum, period. Okay, that is the whole definition of a pendulum. A body that is able to swing, a body that is suspended from a fixed point, like this one, okay, and that body, it is able to swing under the influence of gravity. That's all. Okay, that's all. Let's now try and answer this question. What is a period? Okay, so period is just the time that has been taken. Okay, the time taken. So now the formula for period is like this. Capital letter T, okay, is equal to small letter t over n. This is the formula for period, for you to come up with a period. Where this capital letter T, it means the period. Okay, so we don't use the word P. Okay, we use this capital letter T. Okay, we use the capital letter T. Okay, not P. Okay, we use T. So T means the period. Is equal to, this is the time taken. Okay, the time taken over what? The number of oscillations. So here we call it the number of oscillations. But under waves, we are calling it the number of waves. Simple as that. So there is a minor relationship that is there between the pendulums and the waves. Okay, there is a minor relationship that is there between the periods and the waves. Okay, let's continue. We are finding the what? The period. Okay, we are finding the period there of the pendulum. Okay, so period is equal to, what's our t? What's our time? What's our time? It's 2.08. Okay, over what? The number of oscillations. So now, what's our number of oscillations? Okay, have we been given the number of oscillations here? We haven't been given the number of oscillations. So now the question is, how are you going to come up with the number of oscillations? Very simple. Okay, it's very, very simple. Let me show you. Okay, let me just try and gather space. Let me just try and remove this part. Okay. Remember the diagram I drew at first. Okay, remember the diagram I drew at first. Okay, it was like this. Okay, it was like this. Having this, also having this. So pa, 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 pa. So this is my A, this is my B, this is my C. Then we had something like this. The reason why you had this arrow again, because the first statement is saying and back to the midpoint. Midpoint simply means on the middle. Okay, the midpoint simply means on the middle. Okay, so our midpoint here is this B. Okay, our midpoint is the B. As simple as that. As simple as that. Okay. So now we are finding the N, right? The number of oscillations. Okay, we are finding the number of oscillations. So now listen. For one complete oscillation, okay, for one complete oscillation to be full or to be made, let me take that again. For a complete oscillation to be made, a pendulum, it has to move from like this. It has to swing bar and bar. Like it has to swing bar and back to bar. Let me show you like this. So I'm having this A and C. Okay. So for one complete oscillation to be made, a bulb, it has to move from A to C, it has to get back again to A. So like this. 1, 2, 3, 4, 5. That's how you count the number of oscillations. Okay? That is how you count the number of oscillations. Remember how we were doing the number of waves, the way we were counting waves, like a wave, it has to go from the trough and also the crest. That's when you count one wave. Trough and crest, second wave. Crest and in the trough, another wave. Okay? Remember, don't forget about waves. It's very important. Okay? It's very important. So these two topics, they are interrelating. Okay? There's a relationship. Okay? It's like they are dating. Toxic example. So that's how you count the number of oscillations here. Okay? So now this question is a little bit tricky. Okay? This question is a little bit tricky. Please pay attention. Okay? So now it's like this. Remember the way the bulb was moving, right? It moved from A to C and back to B. Okay? So now for us, since we've now known to say that for one complete oscillation to be made, a bulb has to move from A to C and back to A. That's 1. A to C and back to A, that's 2. A to C and back to A, that's 3. That's 3, I mean. Okay? So now, here this bulb, it moved from A to C and it stopped here at B. Okay? So meaning that here and here, it's what? That's quarter. Okay? That's quarter. Okay? So now, from here to here, it's a quarter. Here and here, it's a quarter. Here and here, it's a quarter. Okay? So quarter, let me show you guys. And under science paper 1, okay, you'll be required to go with the calculator. Okay? You'll be required to go with the calculator. No excuses about that. Okay? No excuses about that. So now let me show you. Okay? This is my calculator. Okay? This is my calculator. Okay? So now for one complete oscillation to be made, okay? For one complete oscillation to be made, a bulb has to move. I guess you understand that. Okay? I guess you understand that by now. Okay? So now this is here to here, it's quarter, not half. Because if we say that from here to here it's half, so I'm going to say here and here it's half. So half it's what? This is 1 over 2, or just the same as 0.5. So I'm going to say since here and here it's half, so 0.5 plus 0.5. So I'm going to come up with 1, okay? Of which this is wrong. Okay? This is wrong. So what I'm saying is half. So half here plus half, this is 1. But see, that's not how you count the number of oscillations. So now from here, this is quarter, here quarter, such that when you add quarter plus quarter, again coming back to quarter plus quarter, you're going to have one complete oscillation. So quarter, what's the half of 0.5? Okay, what's the half of 0.5? 0.5 divided by 2. The half of 0.5 is 0.25. Okay, the half of 0.5 is 0.25. So now we are going to count. Here it's what? 0.2. Since we are saying that this is quarter. Okay, here we are going to have what? 0.25. Okay, so we are going to have something like this. From A to B, it's what? 0.25. What about from B to C again? B to C is what? 0.25. So here 0.25, here again 0.25. Again from C to B, is what? 0.25. Okay? So now the bulb has stopped here. Okay? It has stopped swinging from here, B. So 0.25 plus 0.25 plus 0.25. We are going to come up with 0.75. Okay, we are going to come up with 0. Since our bomb has stopped moving from here, so our number of oscillation is what? 0.25. 0.25. Okay, I mean 0.75. So 0.75. Okay, so this is our number of oscillation. Such that since it's like this, here 0.25, here again 0.25. Coming back again, we count. Here again 0.25, here again 0.25. So we said from A to B is 0.25, B to C 0.25, C to B 0.25. What about B to A? B to A is 0.25 again. Such that if you compute these or if you sum up these, 0.25 plus 0.25 plus 0.25 plus 0.25 or 5. If you add these, 1, 2, 3, 4, 0.25 times 4, 0.25 times 4, you're going to come up with the 1, year 1, okay? Complete oscillations from here to here and back to here, that's 1. Okay, so that's how you come up with this. So our number of oscillations here is 0.25. I guess it's clear. Okay, I guess the explanation or rather the elaboration is clear. Okay, so now we compute again, we divide. Okay, since we are finding the period is equal to 2.08. Okay, 2.08 divided by 0.75. You are going to come up with 2.8 as our period. So our answer here is 2.8 seconds. That's our answer. That's how you solve this. That's how you calculate the period of the pendulum. Very simple. Okay, it's very simple. It's very simple. Okay, so let me just try and remove this so that we come up with the frequency. Okay, so that's how you calculate the period of the pendulum. Okay. Let's go to the next question. Okay, let's go to the next question. The question is saying find the frequency. Okay, so frequency is equal to 1 over capital letter T, which is the capital letter T is the what? The period. Okay, so I'm going to say frequency is equal to 1 over what's our period? Here we found 2.8. So 2.8. So now if you compute 1 divided by 2.8, I'm going to come up with my frequency is equal to 0.4 Hz. So the SI unit for frequency says same applies in dynamic waves. Okay, same applies. Okay, so now the SI unit for frequency is Hz. Okay, so now this is our frequency. So our frequency is 0.4 Hz. So physics is very much important that you put the SI units. Once you don't put the SI units, you'll be penalized. You'll be penalized in an exam. Okay, so this now brings us to the end of our first question. Okay, this now brings us to the end of our first questions. Okay, so these were the solutions. We now move on to the second question. Okay, let's now try and move on to the second question. Okay, let's try and move on to the second question. Let me just try and remove these. Pendulums, this is a very simple topic. Same applies with the waves, wake energy and power. Wake energy and power just requires you to know a lot of formulas, when and how to apply them. Okay, just requires you to know a lot of formulas, when and also how you should apply them. Okay, they are very simple. Okay, the second question, we are having this diagram. So the statement was saying if the diagram below shows the simple pendulum, like this one, but I didn't indicate the diagram below shows the simple pendulum. Okay, so we are having this is a spring. Okay, this is the spring, candamo. Okay, this is a bow, like a bow. Okay, it's a bow like a bow. Okay, so this is our A, this is our B. Okay, the first statement is saying the bob is slightly put to position A. Okay, the bob is slightly put to position A here. Okay, the bob, okay, is slightly put to position A. and then released, okay, and then released, okay, meaning it began to swing, okay, under the influence of what? The gravity, okay. Remember, gravity is fixed, okay, it's 10, okay. So in an exam, you should be using gravity as 10. So gravity is just the same as the acceleration, okay, because gravity and also acceleration, they are having the same SI unit, meter per second square. Very important, okay, very, very important, okay. So now the first question is, state one factor that does not affect the period of the pendulum. State one factor that does not affect the period of the pendulum. State one factor that does not affect the period of the pendulum. Remember what I said, right? Okay? Remember what I said from the definition of a pendulum. I said a pendulum, let me write it here. A body suspended from a fixed point that, okay, a body that is suspended from a fixed point and it is able, okay, to swing, very important point, under the influence of gravity. Gravity, very important point here. Okay, so to swing simply means like to be rotating, okay, like this. Okay, that's swinging. Okay, swing. Yeah. So now, let's talk about the things that affect the period of the pendulum before I go to the things that do not affect the period of the pendulum. So now this question, it's a very good, this is the question which most of the schools